Hello friends and welcome at my channel. Today I would like to compute a derivative of a tangent. There are a few ways to do it. The first one, if you remember, we've been doing the chain rule and the product rule. So using those, I can rewrite f of x equals to tan of x. And if you remember the definition of a tangent, it was the sine of x divided over the cosine of x. So now if we are applying the quotient rule, I think I proved it. If I haven't, I will prove it soon. So you just check it out and you will see how it works. So we have the sine of x divided by the cosine of x. This is not the point to prove it with the quotient rule. I mean, this is nice to have and I'm showing you how it works, but first of all, I want to prove it with the first principle. And this is a kind of additional material. Okay, so let's see. We have the derivative of the sine times the cosine minus the sine times the derivative of the cosine of x, and now we're dividing it by the cosine squared of x. All right. So the derivative of the sine is the cosine. That means we have cosine twice, so it's cosine squared. And the derivative of the cosine is the minus sign, which means we have minus minus, so plus sine squared of x. Divided over the cosine squared of x. And now you see we have two possibilities to write it down. First of all, we can say, well, sine squared plus cosine squared, this is the trigonometrical Pythagoras, and this is 1. So we're going to have 1 divided by the cosine squared of x. This is the first way to write it down. But there is also another one, which is we're just splitting the fraction. We are writing cosine squared of x divided over the cosine squared of x plus sine squared of x divided over the cosine squared of x. And now you see the first fraction obviously gives us 1, and the second one, this is sine squared divided over the cosine squared. I can take, using the power rules, the second power outside of the fraction, and then I'm going to have sine of x divided over the cosine of x. Then I square the fraction, and at the end I just have 1 plus tangent squared of x. So these two are equal. All right, let's put it down this way. So they are truly equal, and we are literally having the same result here. But this is not the main point. I would like to show you how to compute the tangent, derivative of the tangent, using the first principle only. The dogs and the cats are vocal as well now. I hope you enjoy this concert with me. It's not stopping, and we have no time to wait. So let's go for this. We say f of x is equal to tangent of x as well, again, and we are writing it down using the first principle. So we have a limit h towards 0. We have tangent of xo plus h minus a tangent of xo only divided over h. Now let's once again remember the definition of the tangent. That means we are having two fractions now, so we have sine of xo plus h divided by the cosine of xo plus h minus sine of xo divided over cosine of xo divided over h again. And well, now we just bring it to the same denominator in the upper part, in the numerator. So we're just basically multiplying times 1. So that means we're having sine of xo plus h times cosine of xo minus sine of xo times cosine of xo plus h, and we're dividing it by the common denominator now, which is cosine of xo plus h times cosine of xo, And we're dividing the whole fraction, let me change the color, by h, which I can write as h divided by 1. Okay, so let's write it clearly on the next page. So we're still having limit h towards 0. Now I have more space. So it's sine of xo plus h times cosine of xo minus cosine of xo plus h times the sine of xo. And I'm dividing it here by the cosine of xo plus h times the cosine of xo, right? And let me put myself aside. Oh, you cannot see me anymore. That's a pity, but you've seen me, so no worries. And we are just multiplying times a reciprocal of h divided by 1, which is 1 divided by h. Am I right? Think so? We can check it. Now I figured out how to change the pages quicker. So you see, we're dividing by this fraction, we're multiplying times a reciprocal. It's kind of messy notation here, but I hope you can follow me here. And well, now please remember one of our trigonometrical videos where we proved that sine of alpha minus beta was equal to sine of alpha cosine of beta minus sine of beta cosine of alpha. And well, if you have a quick look right here at our numerator, you will see this exactly what we're talking about here. So we are getting limit h still running towards 0. And what we're getting now, we're kind of coming from the right-hand side to the left-hand side. So we are writing it, this is alpha and this is beta, xo is beta. So we are having sine of xo plus h minus xo. And we're still dividing it by the cosine of xo plus h times cosine of xo. And we are multiplying it times 1 divided by h still. Now, as you can see, it goes away. So we just have limit h towards 0. And now we're basically having, well, I can rewrite it as well. Sine of h divided by h, I can rearrange the product, times 1 divided over cosine of xo plus h times cosine of xo. And if you remember, we can split a limit of the product into the product of limits if those two limits do exist. Well, let us see. We have the first one, limit h towards 0, 1 sine of, well, I can just separate it again. This is cosine of xo plus h times cosine of xo. Once again, it doesn't matter how I rearrange it. We can put the question mark here. Still, we don't know, but we'll have a quick look here. And we have h towards 0 of sine of h divided by h. If you remember this one, we proved that this is equal to 1. So it does exist. I have no problems here. But what about this one here? Do we have any problems here? Actually, no, we don't. Because if h is 0, we just have cosine of xo times cosine of xo, which is just cosine of xo squared. So the total result would be 1 divided over cosine squared of xo. And as you can see, this is exactly the derivative that we've been getting with the quotient rule. All right. Okay, guys, thanks for watching. As you can see, I'm back now, and I'll be pushing. I promise you that. Now I go to the beach to swim a little bit. We still can swim on the last day of the autumn 2021. This beautiful country, Turkey, makes it possible. Thanks for watching. See you in the next video. Bye-bye.